Hi, the question says a particle of charge q and mass m is subjected to an electric field E that is equal to E naught into 1 minus ax square in the positive x direction, where a and E naught are the constants. Initially, the particle was at rest at x equals to 0. Now it is acted upon an electric field, so there will be some acceleration into it. So, other than the initial position, the kinetic energy of the particle becomes 0 when the distance of the particle from the origin is. Now, we know that the change in energy is equals to work done from the work energy theorem. So we can say that dk, that is the change in the kinetic energy, is equals to dw, that is your work done. Now work done is equals to force into displacement, and the force on the charge is because of the electric field. So write F is equals to QE, and let us assume that displacement of the particle is for a small distance dx. So if we integrate it from 0 to x, we can get the actual change in the kinetic energy. So this can be written as Q into, instead of E, we substitute the value of E, that is given by E naught into 1 minus ax square. So write Q into E naught into 1 minus ax square into dx. So if we integrate this value, we'll get the change in the kinetic energy to be equals to Q into E naught, where Q and E naught are the constants. When we integrate it from 0 to x of 1 minus a into x square dx. Now differential integration of 1 will be x, and integration of x square will be x cubed by 3. So on solving this further, we can say that x minus a into x cubed by 3 would be equals to 0. So in this case, this value is equals to 0 because it has been given that the kinetic energy of the particle finally becomes 0. So that energy initial and final are both 0. So delta k would be 0. So if you take x common over here, we get 1 minus a into x square by 3. So we can say that x equals to 0 and x equals to plus or minus root 3 by a. Now we take the positive value of the root 3 by a, not negative value, because it has been asked that it is moving in the positive x direction. So we'll ignore minus root 3 by a, and we'll take the answer to be option number 3, that is root 3 by a. So that will be the position at which the initial and the kinetic energy of the particle will be 0. Thank you.